Hello guys. We can maybe wait for a few more minutes and then start. If you guys have any questions in the meantime, I can take them. Yeah.
Sir,
Yeah, go ahead. Yeah.
yeah, actually, I have a doubt in operator overloading. Means which operator we have to select. What happen whenever
Okay.
the programming questions I'm not able to solve the programming question. Whenever they have
Okay.
given any statement, that time I'm confused which operator we have to use. And one more thing is what are the parameter we have to pass.
Okay. Okay. Sure. So I can explain you through function overload itself. The idea is more or less the same. Or if you want me to take a look at this question, I can maybe I can't solve the assignment. I don't know if I'm allowed to do that, but if you give me the question also, I can help you through it, how to approach it.
Uh, I mean, previous whatever the assignment we have means due date was passed.
Okay.
So those assignment we can solve, right?
I think that should be okay. Yeah.
Yeah. So there are means in week 7, I'm not able to do the single means even one problem also. I am
Okay.
little bit confused while
Well,
solving the
okay. Even I
programming
haven't.
assignment for week 7.
Sure. Sure. I haven't looked at the questions. Maybe I'll also take a look at them and at
Okay.
least help you how to like approach the question at least. Yeah.
Okay.
Sure, we can do that. Yeah. So repeat. So it's week 7, programming question. Which one?
All three.
Okay. Maybe I'll share my screen. How do I see the assignment here? Uh,
Sir,
yeah.
one more thing
Mhm.
means just like a data science, whatever subject, whatever courses we are
Mhm.
registered, that time we found that there are the activity questions for each lectures. So here there
Okay.
is no activity question for each lectures, right?
So I don't know what activity lectures are there. So do you mean like tutorials or
No, no, activity
yeah.
questions means activity practice assignment for activity so
Okay,
that
can
we
you give an
can
example?
like we can means in the programming assignment whatever we are solving that time we come up with means we got the solution after due date, right?
Okay.
Once
Okay.
due date will be passed on, then we can get the answer. But
Okay.
before that we can solve the activity questions so that we can uh, get the thorough knowledge that whatever means understanding of our uh,
Okay.
whatever we
Right.
taught
Right.
in the
I see.
lectures that will be covered.
Okay. But aren't assignments also sort of the same thing? Can you give me an example? Like, what do you mean by those activities? Are they like questions that you solve, or like
And
how do
but
they work?
whatever assignment we are solving, it is
Okay.
means whatever answer we are getting after the due date, right?
Mm,
Means
okay.
once that solution we got,
Hmm.
then we cannot recover our marks. Means we cannot again, we cannot give the
I see.
uh,
I
get the
see.
marks for that, right?
Okay. Okay. Yeah.
Does this
Course also.
I
Actually, yeah. So thing is, mm, uh, so there are other TAs also for this course. My part is just to cover the live sessions where I take questions. Actually, the thing is, in regards to assignments and all, that is covered by the other TAs of the course. So maybe you can actually ask in the forum or something if you want more questions or something like that, or write to PMRF support also. As
okay,
far as I,
okay.
yeah, as far as I understand, the this course itself doesn't have any of these activities that you mentioned. So yeah,
But can I write to POD, means
uh,
the program, the sir, so that I can means
yeah, maybe you
they.
can just write to them. Yeah, sure.
So how can I tag them?
You can just
Means
ask in the forum if they're like asking them, or you can raise just mail to PMRF support of your queries or anything specific you want from the course or something like that. Yeah, that
but
should be
is
okay.
there any course specific email ID?
For specific email ID, I don't think it exists, but there exists a forum. You can go there. So I think I have it here. Announcements about the course. Question answer. Yes, yeah, this is the one. So I hope you have access to this SWAM portal. So with Q&A, you can go and access this um,
Okay,
forum. You can post questions here itself. Yeah.
okay,
So where people have posted questions, as you can see, you can ask your questions, doubts, or any feedback you want to give or anything, comments.
okay.
Yeah.
And how
Mm.
many quizzes are there for this course?
Actually, yeah, again, so um, related to those things like assignments, how many and when's the exam, I'm not familiar with them because I'm not handling those portions of this course. So
Okay,
you can actually raise that in the forum. Actually, there are other TAs who will be better positioned to clear this kind of questions and doubts. Yeah,
okay, okay,
yeah, yeah. Or you can always raise it to PMRF support. Yeah.
okay. Okay. Yes. What happens, sir? Actually, sometimes now we are getting partially we are getting
Mm.
things, and partially I'm missing some things. So
Yeah,
that's why
that
I'm not able to solve the programming assignment, and it will be
okay.
means
Yeah, thing is, with this course, a lot of things are built on top of each other. So one concept you need to understand, then sometimes you need to know other concepts before to know the next one. So it usually comes with practice. What I would suggest is do as many questions as you can. So one of the reasons I mostly do these sessions through examples is because you actually get through practice. I mean, if you when you see the actual code itself and examples, then only you actually get to understand what is happening. So that is at least my way of thinking. So what I would suggest is there are a lot of questions on the internet even. If so, there are questions that are there in the slides. There are questions that I try to solve in the live sessions. You can take look at those. I've shared the code also, the codes on um, whatever I covered in these live sessions. So those things, and again, you can very well take look at online resources for more questions. Try to understand what the specific concept even means or something like that. Again, like you said, these programming assignments might be a little tricky. So it actually just comes through practice, is what I would say. The more you spend time with it, the more familiar it gets, and that's how everybody uh, becomes used to it. That's the essential thing. Yeah,
Okay.
yeah. So,
How means
yeah. Mhm.
whatever code you have post, where it is?
Oh, actually, you should get a Google Drive link with all the sessions. You can again mail to PMRF support for that link. There is a common link where all the weeks are in a folder, and like each folder, it's like week one is a folder and week two is a folder and so on. And each of them has the all the codes that I discuss in these live sessions. Yeah, you can take a
Okay.
look at those also. Yeah, yeah. Okay.
So could we solve that? Means could you please take that three questions of week 7?
Yeah, sure. I'm not sure how to even get that question. Let me just check.
Uh, it's a one mail we got that solution for that those questions. So I can
Okay.
get the answer.
Is this the question?
It's an assignment. I'm asking about the programming question.
Okay. If you can share with me, I'm not able to actually find it here.
Okay.
You can put it in the chat also. I can take a look.
Yeah. Sir, I have
Yeah.
pasted the yeah. Uh, I have pasted the link of
Okay.
solution of week 7.
Okay, sure. Let me take a look. This is the assignment 7, right?
No, in the below, the bottom, uh,
Oh, okay, okay. Mm,
in the last, they have given the solution for programming assignment also.
okay, let me take a look. Mm, share. Okay. From here, right?
Yes, from
Okay. Let's see. Okay. So let's go at least line by line so that we understand what the question is. Okay, so we have hash include IO stream. So hope that part is clear. It's just a header file to print. Okay.
yes, sir.
And then we're using namespace standard. So whatever functions
Yes,
are there in that standard, we will have that. After that, we have a class defined, which is class one, which has a member function a equals to 10. And because this is not qualified with anything, it will be private. That is the default behavior in C++. So A is a private member in class one, which we say that it will store value 10. Okay, so that's the default behavior. Then there's a public function. So if we have an object of class one, of type class one, right? So we can call this function inside. So now that we have a void function. So this show itself, that function we can call from outside. What does that do? Now there is a cout with a and then like a space. So it essentially just prints the value of a. This is allowed and okay because uh, the class functions themselves have access to the private members. That is okay.
Yeah, got
Okay.
it, sir.
Good. Okay. Then moving on, then we have a class 2, which where we are similar to class 1 only, where we are saying it will be an integer b equals to 10, sorry, 20. And so, yeah, b is a private member of class 2, and then it has value 20. Now, thing is with public, again, has a function show, which will print b. Okay. Then you're asked to, I guess, to insert some lines here, or maybe a function, I guess, with two
Yeah, they
brackets.
have mentioned that operator overloading. Uh, to complete the operator overloading for the assignment operator.
Oh, okay, okay. I see.
So my question is how I can come to know that it's a operator overloading means assignment they have mentioned the assignment operator, but they have just added b plus x.
Yeah.
So I'm
So,
confused. Can I
right. Right.
use plus operator or assign operator,
So
and
thing is,
why they have used
why
assignment
that is
operator?
okay, okay. So thing is, actually the word itself operator here, as you see. Okay, so yeah, the answer is operator equals to integer x. Okay, so it might look a little weird or a little different, but I'll try to like make you understand. So what is happening is now you have a function which is show, okay, void show, and then this. So just ignore everything and then look at this part. Void show, and then so first is the type of that, then show is the name, and then it doesn't these two brackets say it doesn't take any input, okay. And then from this curly braces, this is the body of that function. Exactly similar to that, we'll have a function, okay, and then a body. Now the body is already given to you. So it will be b equal to b plus x. Okay, that is the body.
Yes.
Okay. Now what it says is in the line blank at line 1 to complete operator overloading of the assignment operator. Okay. Assignment in the word assignment itself in C++ means
It's
equal to.
equal to.
Equal to. So assignment is like, let's say here itself. So integer a equals to 10. Okay. I'm assigning a as value 10. I'm assigning the value 10 to a. That's all. That is the assignment operator. Now what they are saying is now normally when you write integer a equals to 10, what is the value that will be in a?
Yeah, it will be 10 after
Correct.
executing of this
This
int a
line.
equal to
Forget
10.
everything.
Yeah,
Yeah.
initialization. After
Initialization.
initializing.
Right. Forget even the classes that exist. Okay. Now, don't worry that these classes exist or anything. Just if just this line a equals 10 in some main function. Okay. So when I call this function integer a equals to 10, I know that my value in a will be 10. Okay. So this itself, you can think of it like I called some function that assigns the value 10 to a. Okay. Now, thing is with function like similarly how we overload functions, right, to change the data type, sorry, change the behavior of it depending on the input or something. We'll do this exact same thing to this assignment operator. Here it is an assignment, right? So when we call integer a equals to 10, we are sure that by default the value that will be in a will be 10. Okay,
Yes.
but what we'll do here is when we call an assignment operator for regarding this class 2, okay, it will take some integer x. That's the actually one of the part of the answer. You see these brackets, right? So operator equals to think of this whole thing. Sorry. from operator O to equal to is the function, and the bracket says what parameter it takes. So that is the x, which will be an integer. We have to tell what the data type is. So x is the input it takes, okay, and this is the function. Now, operator, the word itself is actually a special in C++. What this actually means is operator equals to operator plus operator division are actually overloading this function, this equal to,
Okay.
and this equal to. So when you call something like this, right? Forget about
Mhm.
classes here. I'm just talking about this line. Integer a equals to 10. What happens is your the value 10 is stored to a. That is the default behavior. But if we want to change that behavior, okay, what we have to do is overload this equal to operator. Equal to is the operator itself. Operator as in you can think of it like a function itself. Okay. What we're actually
Yeah.
doing here is uh, changing the equal to operator behavior. Okay. So essentially this is like oh, sorry, maybe I'll um
Sir, I have specific doubt over here.
mhm, yeah,
They have mentioned operator equal to, in the bracket they have mentioned int
integers.
x. When
Yeah,
to use reference and when to use a call by value. Means
call by value. Right.
in the
Uh,
operator we are
mm, mm.
using reference most of the time and it will be the constant one. How can we decide that
Depends.
the reference
It
we
dep
have to
yeah.
use or
Hmm. Yeah, it depends on your the question you're solving. So here there is it's like a call value, right? Uh,
hmm,
Ideally, it is okay if you don't even pass by reference because let's say you're passing some value 10 or something, then it you can't actually pass by reference because that's a specific value. So in that cases, in those cases, it will make a copy, store that 10 into something called x, and then perform this operation where b equals to b plus 10. Okay. It really depends on your situation, like what we want to do with um, the code. So references are usually, how do you put it, used in cases where you want the data to be shared. So when you pass it to a function, so let's say I pass, I like I showed in the first class, vectors, right? So standard vectors. Maybe I can pull up that example. Okay. I'll just pull up the example. Was it in week two? Let me see. Ah, yes, there is a reference file. Mhm. Okay. So, for example, let's take this. So I have an integer of size 5. Okay. This is what I'm defining to be the size of my array. Okay. Now I define something called a standard vector of type. The values it will have will be integer. Okay. And A is the object. Okay. Here now we know that classes and all. Um, so standard vector is actually a class. Okay. Templatized class. So of integer um template, and then integer data type it will take, but actually it's a template. I'll
okay,
maybe
yeah.
cover templates after. Well, this was the plan today, but anyway, we can take doubts and then maybe we can cover that. But let's be clear in the concepts also. So A is the object and size is the size of what the standard vector will have. Okay. So while constructing itself, while declaration itself, we are so its constructor will be called, right? So passing the value, and then the constructor of standard vector knows that it will use this size value, okay, and then construct this standard vector. Okay, nice. Then what I did was okay, yeah. So the pointer to the first value is what I store in Q as an integer pointer. This is one way of accessing the values in A by pointer, and another is, so this is I just printed them. Then I call two functions f and q, which is passed by first one is passing the pointer p, Second is passed by reference, which is with ampersand, as you can see. Here,
Hmm.
uh, do note, I represented by B. So thing is, whatever is the name, or you can think of it like an alias given for that vector will be used here. That's okay. Can't use A because it doesn't, this function doesn't know what A is. It knows B, which is what because A is what I passed and B is what it is here. Okay. Now, uh, thing is, because this is a reference, the actual standard vector object A, when passed by reference here, in this case, is exactly the same thing. So you can think of it like the all the data structure, all the memory, even values, the whole set of the whole thing is exactly the same. B is just another name for it. So what happens in references is you actually don't, I mean, you definitely have access in other functions. So if function wants access to this vector A, we just pass it by reference. In the process of doing that, what we are actually doing is giving another name for it for the same object. References are basically doing that. So I'm calling it B here. I can actually call it A also. It doesn't make any difference. It is going to work like exactly the same. The whole code will work. This part of the body. Only thing is that because I want to change the actual object, I'm passing by reference. It's actually the same thing I'm accessing in a different place. Okay, because here because I've declared A here and I want to access in this place to for this function to know what this vector is, I have to just pass it. And because I want to change it also, I'm passing it by reference. Okay. The other way of doing the same thing is passing by pointer. Both are essentially the same thing. It's just what you're comfortable with. So um, it's just that passing by reference has one added advantage that B here is a vector. So you can use all the member functions and all the niceties that comes with having a class. So you can call a dot size, you can do standard transforms, you can do from algorithms and everything. You can have iterators. So it's in general, not even for vectors only. You can have all when you use other data type, other this kind of classes, right? Standard array, standard vectors, stacks, queue, standard queues, stacks, decks, sets. So you can use their member functions also in the in the body. If you just pass by
S-
raw, yeah, sorry,
yeah, got it, sir. You mean to say whenever I am calling line number 36, then it will be call line number 7, fn,
correct.
that function, right?
That function, yes.
And whenever I am calling 37, line number
Seven,
37, fn of A, means
right?
in the bracket A, that time it will call line number 15,
15.
right?
Correct,
So,
absolutely right.
yeah, because of
What do you
the
think?
reference,
Hmm, what do you think this
it is
property of C++ is called?
it's a call by reference, right?
Right. But what I'm doing is, oh, okay, I'll repeat what
It's
I'm
a
actually asking.
overloading. You are
Exactly.
overloading.
Absolutely right. Yes. This is exactly what function overloading is. So you have the
Yeah,
same function, but depending on the parameter that it takes. So I have an integer pointer here. I have a standard vector of reference. So depending on the input, the function then knows the code actually knows which function to call, which line of the function to call. This is
yeah,
exactly what function overloading is.
yeah. Got
Essentially,
it, sir.
this. Yeah. Yeah. Okay. I hope this is
Uh,
clear,
the
right?
say, yeah,
Okay.
that I got it.
Okay.
My second question is like when to use const operator means
Yeah.
when that reference will be the constant value and when
So,
we don't
right.
use the const.
Const. Yeah. So const is something I covered last class itself. So can
Okay.
show probably like talk about that. So let's take an example here. So I have integer I equals to 0. So I is a value. Okay. And I'm storing 0 in it. That's good. Now, what I will do is for this variable I can have a const reference. I can have a const pointer to the same thing. What
Yes.
is essentially happening is ref is a reference, which is basically like I said, it's the same thing, but I'm calling it with an alias, the name only. That's the
Yeah.
reference. The extra thing I'm
And
qualifying it with is a const. What it means is the reference cannot be changed.
yes.
Okay. Okay. But and also the pointer, a similar idea. So I have an integer pointer of with the address of I, okay, and that says const. So I can't change the value of I, okay, using this reference and pointer
Mm,
because they are const. Okay. Now imagine a situation where you just have you just have in a function access to reference and pointer like ref and ptr, which are const qualified. So you can't change the actual value they point to.
mm,
Both of them point to the same thing. It's just that you can't change them because they are const qualified. Now, this is what the concept of const cast was, where the reference and the pointer themselves cannot change the value. Okay, but the actual value is not const. It is not const qualified. The value they are pointing to itself is not declared as const. I
mm,
itself. Okay, so temporarily you can use const cast to cast the ref with a integer reference and then then try to change the value. So this will work. So
mm,
if you have integer I equals to 0, you can write integer I equals to 9. That will work because you have access to the direct value itself, the variable for that, right? That is okay. But let's say you don't have access to I in some function, in some place, but you have this reference and this pointer, which are const qualified. Okay, then you can't directly use them. So ref or PTR itself, you can't use to change the value because they're const qualified. But what happens is if you have, if you know that the actual value I was not const qualified, then you can temporarily make it non-const. Okay, so what I've done here is I've done a const cast where I take integer reference for ref and then point it as 9. So if I try to run this code and print I, I'll get 9. Similarly, if I try to do pointer ptr equals to 11, this will throw an error. Ref equal to 9 will throw an error because ref and ptr both are const. But if I want to change the value ref to 9, instead what I can do is const cast with template, taking template integer reference, right? Integer ampersand and ref as the object as the parameter. This will change to 9. And then if you try to print it, you'll get 9 here and 11 here. Here it's essentially, I am taking a const cast, changing the pointer to integer pointer. And then to access it, I have to dereference. So this pointer is essentially a dereference operator. So to access the value, and again, so think of it, the whole thing here. This is the pointer, integer pointer. I'm dereferencing, putting the value 11 and then printing. So I'll get 11. So the idea behind const, when to use and all, is actually this. So when you want some things to not change, essentially that is what const does. Now, if you have a variable I, let's say I would have done it. So instead of this line, I would have had this line. Then none of this will work because the original value variable itself has been declared as const, and C++ will follow the rule that this value will never change throughout the whole code.
mm.
I can't
Got
temporarily
it.
cast, I can't temporarily cast it as const also. Okay, that
Yeah,
is the
but
main,
in case of overloading,
yeah.
sorry, in case of operator,
uh,
how to decide that
yeah, so
that
that's the,
parameter should be constant?
it's up to you. If you think that whatever variable it is taking, so let's say I have a parameter like here. Yeah, I have a parameter here. So I can have a const reference to it. So I can't change. So if I have a const reference here or a const pointer, I can't change the value directly. So I won't declare like qualify const qualify them here because I want to change B and P, the actual value A, okay, by their reference or their pointer. So here, because I want to change the values by accessing B and P, I won't const qualify them. That's it. So in this example, at least you know that you won't change the parameters that it takes, then you don't const qualify them. If you are not going to change them, so let's say instead of just integer pointer P, I have some other values. Okay, let's say here, because it is a
So
pointer and it is a pointer and I
sorry to
don't,
interrupt you.
yeah, yeah,
Yeah, could we, I mean, so, whatever week 7
mhm,
programming assignment question number 1,
yeah,
can you please show
explain that.
me that?
Sure.
Yeah,
Okay.
one.
Yeah,
I
I'll
have
just,
question over there.
okay, I'll explain this one and then move to them.
Okay,
So
okay.
the idea is that, so because let's say there is an integer pointer P, right? I don't know the size of this array.
Hmm.
Okay, here I have hard coded it to 5 because I knew it was 5. But let's say the size is not known here. So what I can do is actually pass this here and then declare it as const int size. Nothing
Hmm.
stops me from not making it const. That's okay. But the point is, in this function, even if I change the values of p, the size of it I won't be able to change, right? Because it is a part of a vector class. I can resize it, but to resize, I need to know the that this is a vector class. Here I can do all those things. Okay. So an example here would be that I declare the size that I pass as const so that I know that I won't be changing this value. That's all. It depends on your use case, and then that's how you can decide if you want to qualify it as const or not. It's just a good practice because things that are const won't change if you know them, and then let's say they get changed, then compiler will throw error or even runtime will have errors. So it makes debugging also later easier. That's the only thing.
Okay,
Okay.
okay, okay.
I'll come back to the questions. Yeah. So just a second. Yeah. So very similar to function overloading, like I just showed, there is an operator overload.
See,
Hmm,
sir, here they
hmm.
have used b equal to b plus x, right?
Yeah.
But if I have created one object for class
Hmm,
2,
hmm.
and I want to just assign some value to b, then obviously b is a private
Right.
member function,
I remember.
member
Yeah.
variable.
Yeah.
Then means with the help of get and set, can I
You can.
set the value with the help of set?
Yeah. You can. Absolutely. It's
But
just
that time, does it
hmm,
call the operator, assignment operator, or
no.
does it call,
It
means
calls
we
the
have to call set
yeah.
function
Yeah.
method?
It's like if you explicitly say like void set, then give bracket integer x or something, and then write the body, then you're actually calling a function. It's not assignment. It's like you're actually calling a function, and in the body you can have b equals to b plus x. You can write a
I
set function
sorry to
also. Yeah.
interrupt you, sir.
Uh, yeah.
Sorry to interrupt you. I will
Mhm, sure.
reframe my question that
Mm,
if that B is not a private, it's a public
correct.
member,
Yeah. Right.
then what it will do?
What it will do in what case?
If I have created one another object, let's say object T2, and
Mhm.
T2 dot B equal to
Right.
30. I have put like that.
Ah, right,
Then
right, right.
what it will do? It will call assignment operator, or it will call just a constructor. Means
It will call the assignment, right? So think of it this way. The constructor is called for the object. So let's say class 2 is there. You define class 2 and okay, something like, yeah, actually something like this. So imagine T1 is there. So class 2 with T2. When you
Hmm.
try, when you declare the object, that's when the constructor gets called.
Yeah,
And
but
because this one doesn't have any constructor we have given, it will use the default constructor which doesn't take any value.
yeah,
I can show you how a constructor also looks. That will be a little easier to understand. Just a second. Just check which week did I cover. Ah, yeah. Yeah. You're able to see my screen, right? Okay.
yes,
So here, what we have done is this is a constructor. So for the complex class, so class and then whatever name you are giving to the class, same thing when you give, it's essentially the way you distinguish which one is the constructor. So in
hmm,
constructor, if you actually, so this constructor actually takes values. So two doubles, okay? And then with this colon, after this colon is sort of like where the assignment happens. So real, which is a member of this complex class, sorry, member of the complex class, it sets the underscore real, which it takes from while getting constructed and then sets it to real. Okay. Similarly, underscore im is set to im. Now, in the example that we saw, it was like class underscore, sorry, class T1. That's it. It doesn't take an assignment. So the constructor is just the default constructor. When you write T1 dot B and then equals to or something, then you're using the assignment operator of the class.
okay. But
This is what,
if let's say, uh, yeah, got it, sir, got it.
yeah, got it?
Means it will
So,
not call the constructor, it will call assignment operator.
yes. So
But
constructor is called
can
when
I,
the object is declared. Yeah.
yeah, yeah. Can I have a assignment operator means overloaded assignment
Yes,
operators?
you can.
Then can I have a two overloaded assignment
You can.
operators? Means one will be the just passing as a int x,
Yes.
and another will be the passing object of that class.
Object of that X. So by reference, you
No,
said
that
in
class, because int x is not a part of that class. It's not a member of that class,
correct,
right?
correct, right?
Then I want to assign the operator. Means I want to assign the declare as a assignment operator which is passing object of that class.
So let's say what we saw, right? So something like operator equals to, and then it takes integer x. So
Yeah.
here it is already known that you will take integer x and then use the when you use the equal to operator, and let's say you pass integer x, then only this specialized function, that whatever body you give, okay, here, that will get called.
Mm.
Okay, just to put it in, and then whatever code you have, you can have. Okay, now uh, by default, like let's say I didn't have this overloaded operator, it would have used the default assignment operator. Let's say T1b equals to 10 here.
Okay.
Okay, so now since I have overloaded, I can have b equals to b plus x.
Equal to b plus x.
So what happens is when I call this operator with value like, so essentially with this equal to operator, the bracket integer x is actually 10 now. See the difference.
Okay.
So because think of operator equals to also as a function itself, like here double distance and then take values, and then there's a body. Think these operators, these things which are called operator equal to, operator plus, operator division, or whatever, they're also essentially function. It's just that the look is a little different where you're accessing T1B. Assume again, like you said, assume B as a public member. And then when I use equal to and then 10, this is essentially like operator equals to is called with passing the value X or 10 here. So if I overload equal to with this function, let's say this part wasn't there, the one I have highlighted, then T1 dot B equals to 10 will make sure that B has value 10. Okay. But when I add this part of the code where I've overloaded equal to operator of class T1 with B equals to B plus X. So what happens then is whatever value it already had will get will have 10 added to it. Let's say it was 10 itself. So then 10 plus 10, 20. The value of when you try to print B, you'll get 20.
Sir,
Hmm.
but I don't want, means can I have a two operator
Overloaded.
overloaded?
You can have
Means
as many overloads as you want. Yes, that's okay.
then it will call the object of that class. It should call the object of that class. Then
No, no.
how can I write that, means
It's not
declare that
about the
operator?
no, it's not about the object of the class. So when you have equals to and all,
Hmm.
um, yeah, like here for example, right? So it's we used for this uh, member variables. So here I used for the member variable. Okay.
Yeah, got it. But
Hmm.
how I can write? How should I can, means how I can write the uh, or declare the operate assignment operator which will take the object of that class?
Oh, okay. So normally, let's say the class itself, you have a thing called this operator, which is by default the pointer to the current object. The word this itself is a pointer. Uh,
Yes,
so
yes.
you can explicitly access B like this. So for this class T1, which has a member B, you can access that it by this then arrow B.
But that time B should be the public member.
Now here's
It
the
should
thing.
be the.
It need not be. So this operator is itself accessible inside the object itself. So like we have this class, right? So private, double,
Mhm.
public. The whole class definition, the body itself is from here to here. So the word that this operator, this sorry, not the operator. This is a pointer here. The THIS. This is accessible only inside this body. It by
Oh,
default knows which. So let's say you call this, right? Whatever object you declare, it will always point to that object's pointer itself. By default, we have an operator like this. So you can just use this with a pointer and then access real, imaginary, whatever. I can do it here. I can access real, imaginary, whichever I want.
okay.
Yeah.
And instead of this, I want to use operator overloading. Then how I can write?
Operator overloading, then it depends, right? So for example, here equal to operator or plus or something. Then it will just change the behavior you're doing with the class. So let's say equals to like we saw now, right? Integer x, then I'll have some body. I can have like operator equals to, but let's say this time it takes double x. So then I want it to behave a little differently. So b equals to uh, b plus 2 times x, let's say, or something like that. So
Okay.
then I can have different overloads depending on the type it is taking. Obviously, your b also should be changed accordingly. That's where templates come. So you can have a templatized class. Okay.
Hmm.
So,
Yeah. Yeah. Got
uh,
it, sir.
yeah. So maybe this T will determine what is the type of B. So T as B, you can have. Let's say this is public. So then the template will decide if it's a double, then which operation or something to use, like that.
Yeah, got it.
Okay, great. Hope this is clear. Yeah. Okay. So I can probably summarize what I like discussed last week then. Okay. Right. So this I discussed just right now, but maybe I'll summarize again. So we saw const references and const pointers. Those uh, you guys can see my the screen, right? Okay, just give me a second. That is okay. Yeah, yeah, okay. Right. So uh, the idea is that let's say I have access to the values of I, but through a reference or a pointer. But the trick is the slight uh, mm, thing to note here is that it is const qualified. So I can't change the value of stored in I directly. I can't just write ref equals to 9 or dereference the pointer and set it to 11. But I can still change the value if I know that the variable itself is not const qualified. So I can temporarily remove the constness and set some values, either by changing through this is the C++ way of doing it, either by changing the integer reference, okay, and then passing the ref object to it as a parameter, or I can just C style cast it as int ampersand like reference and then set it. So this is the C style, this is the C++ style. The reason to obviously, since it's you're writing C++ code, the reason to do it this way is it's cleaner. It says your exact intention, and it is less prone to errors because when you typecast this way, sometimes you might miss some other stuff and what you're typecasting. So here it is quite explicit. So that's the main reason to use C++ way. Similarly, you can even use this here. So here we saw for const reference, integer like integer reference, right? So similarly, you can do it for pointers also. So integer pointer, const cast it, then dereference that, and then set the value to 11. Absolutely okay. You can even do it the C way, which is bracket integer pointer bracket. That's it. Okay. Next we saw is yeah, when you're passing const characters, right? So that itself you like let's say I have a print function which takes const character string, and I have a const character pointer of this C, the strings, right? I can't call print C directly because there is no print function with this const qualifier. So the two ways I can either function overload it, okay, with const. So what happens normally then is you have to write both functions. If they're doing the same thing, it's just that because of the arguments that you're passing, one is const and one is without, then you don't you then it's like you're repeating the code. So to temporarily get away with the C++ way, you can just const cast it to character pointer so that this definition gets called. Because temporarily C, the small c object is sorry, excuse me, is treated as character point. Similarly, you can do the same thing with just C style of const casting where it is character bracket character pointer. Okay, then okay, yeah. Then we look at some ways this const cast can be used for even classes itself. So yeah, like we were just discussing, so we have get functions and setter functions here. These are not assignment operators. They're more like um, just function calls. Now, thing is, as you can see here, it is const qualified is what I've written. The reason I mean, it's okay if you don't write it also, but the idea is that this function doesn't change any value of the member variable. Hence, it is just const qualified. That's the idea behind even writing this function as const. Okay. Now, it returns I underscore, which is a private member, which normally you don't have access outside because this is private. So a getter function will help you do that. A setter function will take a value integer j and set it to the internal variable. Okay. Here I've written a constructor also for the class, which is a, and then it takes integer I while getting declared. So that when the constructor gets called, it sets the input I to its own private member variable, which is I underscore. Okay. Then outside this class, I have a function print, which takes character pointer string and then prints it. Okay. Now, again, similar to previous example, I have a const character pointer of hello world. So I can print it by just ignoring the const of constness of C by const casting it to character pointer. Okay. And then let's say I declare the uh, A, sorry, the small a object with type A, but again, it is const qualified. Okay. So then what happens is when you try to set the value 7, you can't set it because the object is now const. But the original value I underscore was not declared as const, right? So directly doing a.7 won't work. So what you can do is temporarily cast the a with a reference. It's you can think of this as a temporarily you are treating a as a different is as a non-const a ampersand. So like as just data type a without the const. Okay. So and then you're using the set function dot 7 dot set with passing value 7. So it will easily set I underscore to 7. Then if you print it, you'll get that it is 7. Okay. Now, yeah, you can't const cast a itself to a. That's not allowed. You have to have a reference to it. Yeah. Then yeah. So references is what we saw, and I'll maybe put this in a file for today and then share this also. Um, operator load. Okay. Yeah, it's not exactly completely compilable code also, but I guess the idea is clear. Right. Okay. Then classes also okay. Done. Okay, this way. So okay. Next we saw is a reinterpret cast, where you're trying to treat inbuilt variables like long, double, integer as some other variable, uh, other data type. I mean, sorry, not the inbuilt variables, inbuilt data types as some other data types. So yeah, like putting L equals to some pointer D, this will throw error because long is of different size than double. But then if you explicitly cast pointer D as long and then put it in L, this is C style explicit typecasting, which will work. Or you can do one thing is use reinterpret cast in C++, which exactly declares an intention. As you can see, you can do a lot of typecasting with just brackets, but the intention is lost in C. Okay, so with explicitly using words like reinterpret cast and all, you actually say what is your intention. Now, that's what we did for L, and then so on. And then we saw static casting, where during compilation itself, it knows which like casting to do. So here it is integer. Uh, so like there was an implicit casting where you're casting a double to an integer. So it implicitly does that. It will have some loss of data, but that's okay if we are okay to for the code, because it's a 64-bit number being typecasted to a 32-bit integer. So yeah, with static cast, you're actually explicitly saying what is the casting that you want to do. So there'll be a C++. This is the C++ style of explicit typecasting. Then if you try to print those values IND, then you can just check how much loss of data was then. Similarly, from integer to double also, it be uh, won't have any what do you call it? Um, Loss of data in a way, because you're storing in more bits now. Okay. Then we saw is again the same thing with pointers. Um, just that pointer v here is a void data type, so you can't cast implicitly. Void pointers can't be typecasted to some other inbuilt data types, but you can always typecast any inbuilt data type to void pointers. So it's essentially like saying I have a pointer which I know its data type, but I want to forget what its data type is and pass it around. Void allows you to do that implicitly. But if you want to if you have been given a void pointer, but you want to treat it as an integer pointer or double pointer or something, then you have to have explicit typecasting. Okay. So like here. So I have void pointers. I want to explicitly treat it as an integer pointer, then I have to typecast it either by the C style ways, so these two, or the C++ style way, which will be with static cast. Okay. Right. I hope this is clear. This is what we saw last week. So today we'll look at some templates. It's also a very important concept in C++, where you can actually, what do you call it? Try avoiding writing a lot of unnecessary code. And during the runtime itself or compilation itself also, actually templates need to be compiled and known. So that is one thing you have to remember while using these functions, templates with any function or as such. So the nice thing is that you compiler can do a lot of optimizations. And during like in my research also, I routinely use templates because then I don't need to write the same function many times for different values. Right. The code almost remains, the code essentially is exactly the same, but depending on the values it takes, okay, some of the parameters, which I know will be known at compilation time, then compiler can do a lot more optimizations. So from that perspective, it is quite useful. Okay, let's take a look at some examples. Okay, again, we'll start with function overloading itself. So I'll have hash include. String, yeah. Okay. Another thing, I hope the questions that you asked about assignment, sorry, the programming 1, 2, 3 are clear. We just discussed line 1, but do you want me to discuss the other two also? Yeah, okay, I guess we can then, I'll just continue the session then. Okay, that's okay. Um, yeah, okay, let's see. So what I'll do is I'll declare, I'll write some functions which will be like integer max. and then it takes integer x and integer y. Okay. Then what it essentially does is if uh, x greater than y, then you return x because that is maximum, else just return y. Okay. You can write the same thing with string ternary operator where it will be this way, return sorry, x will be x greater than y. If it's true, then you return x else y. Same thing, just written in a different way. Technically, the otherwise these are actually slightly different, but I won't get into that. Essentially, for understanding code-wise, the behavior you can think of them both to be same. It's just comparison of x and y, and then return if x is greater or y is or else y. Okay, so yeah, there is this one uh, way of writing the code. Then what I'll do is I'll have same exactly the same thing, but with doubles. Okay, double x, double y, and as you'll see, the code actually essentially doesn't change. It's just that the data type has changed with x and y, but comparison operator again here also it's like a overloaded operator. It will get it will compare x and y as usual because they are both doubles, so there is no issue with comparing them, and then return accordingly things. So sort of like to avoid writing the same code multiple times with multiple bodies, you can actually just write a single code, and depending on the data type, it will infer which function to call, like how to even determine all the data types. That's where templates come in. Okay. One way of doing the same thing is, hmm, yeah, just give me a second. Yeah. Ah, no. So using macros. So this is, let me just uh, we'll have then I'll use a macro called max. The think of it like the function itself that we saw max itself. I'm calling it as with a macro max. Then probably do this with that's fine. It's just then what a macro does is it takes you can define it anyway. So here I'm defining to take x and y as two inputs, and then I have to be careful here. It will explicitly compare x here. Yeah, with y. Okay, and then the whole thing. Whichever I'm like this comparison itself, I'm using a ternary operator. If it is true, it will return x, or else it will return y. Now the for the body of max, I'm then closing the bracket. Okay, I hope this line is clear. So here essentially the same thing which was written in a function, I'm writing it as a macro. Difference is that function call is explicit. It's like there is a code, there's a PTX and everything. Sorry, not the PTX, the assembly code and everything gets generated. Then, but in macro is more is a pre-processor. Even before compilation happens, these lines get executed. What I mean by that? Let's write the body for main. So integer a equals to 5 or 6, and then I'll have b also. Sure, equals to 8. Then I'll have double p equals to 7.5 and d equals to 9.2. Okay. Now, the nice thing is that because I don't want to repeat the code, using the macro is actually absolutely good in this case. I'll show what I mean. So let's say I want to print standard cout uh, max. Okay, I'll just print the max for mhm, max with e comma then and the similarly I'll do it with c and d. The nice thing is that I don't need to repeat my code. I'll leave it as integer while return. Because this is like this function will have same body for every data type. I don't need to actually overload the function and call again and again. I can just write a macro. So what happens here is during compilation, like think of it like even before compilation, a macro says this part of the line in the code, max with A and B. It will replace this whole line, like essentially just copy paste here, put the values it is passed. So I put A, so it will put A here, B here, A here, B here. Okay, in the whole code. The pre-processing step is done. Okay, then the compilation starts. Compiler sees that it has standard cout, then this um, operator, then the print for max, then again this as a bitwise operator, and then after that, here it actually sees the code that was replaced by the preprocessor. Then it compiles the whole line into whatever assembly code, then machine code and everything. The idea is that I replace the need to write this function many times with a macro. Okay. Now this will let's see the output also. This template to so the max, as you can see, is 8 and here it is 9. So that's what it got printed. Okay. So this is a C style way of doing things where you're using macros, and normally macros are not um, like one has to be very careful with them. You should not use them if like just you have to be really careful because since these are preprocessors, and as we saw before also in previous session, it blindly replaces the values. So it takes some values, let's say you have defined it this way, it just blindly replaces. And if you miss some code, like written it wrongly or something, like incorrectly, debugging that becomes is a mess because this is the pre-process. It happens even before compilation happens. So there are cleaner ways of doing the same thing without macros. So like specifically in this example, you can use templates, and sometimes people use uh, macros for defining certain part of the code during compilation time. So it will get compiled or not. So in those cases, C++ 17 from C++17 modern C++, you have const expression. So we looked at that also. So const expressions, you can like it's an extended version of that. So const expression need to be combined and constants. Okay, that expression or that part of the code. Let's say if you want to say I want to compile only this region of the code if certain thing is satisfied during compilation, and if you pass the flag or something like in your file accordingly, so that portion of the code will get compiled, and you don't need to worry about like you can replace those those kind of codes which you were using macros with const expressions. So modern C++ has features like those where you can which you can utilize to make your code more readable and use those like handy features now. Yeah. Okay, now let's look at uh, how to do the same thing with but with um, function templates. Yeah. Okay. So then we'll write a template which will take, let's say, class T. Okay. And T will be the data type for that function, which I saw in the first place here. So it has to know which data type it is returning. We'll just call it by a generic name T. And because it is templatized, it will know which what we mean by the data type. Okay. So we'll have xt1 and then just have this the original line as return. Sorry, x greater than y. So you'll have x else y. Just this ternary operator will do the job. Now I have this function like return a templatized function. Great. Int main. So main always has to be there. So I'll declare the same thing which I did. So integer a equals to x, b equals to 8, and then double of c equals to, let's say, maybe change the values this time. 4.8 and d equals to 1.8. Let's make them 6.9 and 8.5. Yeah, then what I can actually do is I can store these values. So integer, right? So integer I max. Yeah. Uh, so so I max. Then I can call this max function. Okay. It will normally functions take parameters. Okay. So like bracket operator. So I'll pass a comma b here. But what happens is because it's a template parameter, templatized function, you have to actually have pass a template, which will be integer here. Similarly, I'll have double max, which I'll pass double here and pass the values d and d. So nice thing is because I passed the template, okay, so this function itself knows there's a template t and it's expecting inputs of type t. In this case, it will expect doubles and return a double. Okay. So the type of these values are also automatically determined. I can actually use integer here or auto. Both are okay. So this is another feature in C++ where the type of that variable is determined by the return type of whatever is in the assignment. So here the assignment will be integer. So it's here the return type is automatically determined. So this is one way where um, C++ becomes sort of Python-like, where the variables data type you need not know. You can write most of the functions like through just their assignment, and compilation will take care of the assigning the data type. Still, the speed and fastness of C++ will retain because during compilation time it knows the data type, so it will do the optimization in that sense. Okay. For now, I'll just explicitly mention them.
So,
Yeah, go ahead.
yeah, in line number 9, we have mentioned that A is an integer and B is also integer. But we
Yeah.
have initialized with means float values, right?
Yeah. So here there you'll have implicit type passing, but actually that was not my intention. Sorry, my bad. I still want them to be integers. Yeah, yeah. Sorry about that. Thanks for pointing out. Okay, so double is what I said. Okay, now let's print them. We'll have I max and value itself I'll print, and in the line, similarly, I'll have D max and D. Okay, well and good. Let's compile and see. Great. So here it works as expected, where we are comparing integers 6 and 8, which will be 8, and then doubles with 4.8 and 1.8, where the maximum is 4.8. Uh, Essentially, this is what a template works like. Like you pass the template parameters, and then uh, you can have multiple parameters in the template. Here, they just used one. Okay. And then the types of these values are determined. So this is essentially what a template looks like. A very important thing to note here is that uh, if I comment these lines, let's say, so when you compile this code, this whole thing will just get ignored. What I mean by that is when compilation happens, a templatized code like function actually doesn't exist in the compilation. Like you won't find its trace or anything until and unless you have a specific like call. So like I'm saying that I want to call max here and I'm passing the template integer. That's when the uh, template parameters function itself gets created like a code. So uh, this actually never, this line of code actually doesn't exist ever in a way you can think of it. But when I call integer, what will happen is I'll have int max, int x, comma, int y, and then return like this line itself. This function that I printed, okay, this will get created. Otherwise, this never even exists. If I don't call this function and call this function, imagine, then you can think of it like integer, I replace it with doubles. This function will exist. Because I'm calling both definitions will exist in the code. Oh, sorry. Okay. So as such, a templatized function in itself doesn't exist. Only when it is called, compiler will templatize the whole thing, make the function, make the body, everything, and then technically overload it. Okay. Because this is like a overload function. Okay. I hope this concept is clear. This is essentially what templates are. Okay. Okay, okay, nice. Yeah, if you have any other questions, I can take them. Else, yeah, that's what I wanted to cover today, actually, templates. Yeah. You can have templates in classes also, essentially the same thing. In it's just that you have to use templates to declare them. But yeah, the idea is essentially the same. So, Yeah, so like I was saying, if you guys have any questions, I can take them, or you guys can feel free to leave also. That's okay. Actually, yeah, another thing that reminds me to function, like if I talk about function and the operator overload, and then write another operator overload too. So uh, I'll have integer name. That's okay. That's like boilerplate code. Sorry, boilerplate code. So you might have seen one operator is the bracket operator. So we access, let's say there is a standard vector integer a of, let's say, a size 10 or something. Yeah, sorry. So to access its values, we give like a loop, let's say for integer I equals to 0, then I less than size, which will be 10, and then I plus plus. So, and then let's say I access its values and give it I itself. Now what I'm doing here is I'm actually using the bracket operator, this one, okay, which will be um, uh, like it's also defined inside the class, but like we saw, it's designed something like this. So operator with brackets, and then uh, like whatever, if it takes some values itself or it doesn't, and then a body. So essentially, yeah, essentially, so the body uh, can return like a pointer. Okay, it depends on the implementation. You can have like a pointer to the internal object of A. So let me call it as APTR. Okay, and then it's like plus I, and then dereference and return that. So here it can take the integer I or size underscore t. Like it could be overloaded also. So size underscore t is usually like sort of preferred because it's the largest size you can have for anything. So that is also like you can have integers also, of course. You can pass integers here. So it's overloaded. And yeah, these operators explicitly the word like the text that you see here, operator word, right? With this one, like brackets equal to plus, they can be overloaded. Yeah. And it's a very implementation specific thing. So as in there are some data structures you might not, so let's say you write some custom classes, right? You might not have written a bracket operator like this. So using accessing each of the elements by this like using brackets, you might not be able to do, but you can still use pointers or any other way of accessing those values and then write your like write your code. Yeah. So if your class that you have written custom class that supports bracket operator, then you can use it this way. Because sometimes when we write classes as part of my work also, so we just because we just care about the pointers usually, so we don't worry about this is also dereference actually. We explicitly dereference rather than sometimes use bracket operators. Again, it's a completely user choice dependent. So essentially the thing that happens here is the same, so you don't have to worry. Yeah. It's basically how you want to do, how you want to write your code and access the values. It's completely up to you. Okay. Yeah, like I was saying, you guys definitely should practice these questions, and understanding the concept becomes much more clearer when you do more and more questions. So definitely do try to read the code and then try to understand what you think should happen. Uh, you can always just write the same code manually and then compile and run it and see is what you are expecting is it the same thing that's happening in the output. You can put print statements and see if a certain function is even called or not. You can try to probe into the code actually. It's actually definitely encourage that because that's how you actually learn. So yeah, do probe the code. Try to understand from just reading the code, what ideas do you think, what's happening in the code. And if you don't understand some part, then do run it and see, and then try to understand, okay, this is the part I don't understand, but if I can probe it a bit more, try to print some stuff and then see like exactly what is happening. Okay. Because sometimes like with classes, right? So you have these constructors and destructors. So when does a constructor of an object gets called? When does its destructor gets called? Um, like things like that. And let's say in some order, or is there an order followed to it or something? So yeah, things like that. So yeah, you can print stuff and then see also. So Okay, guys. I wish you the best. Do practice, like I was been saying. And if you have any questions, you can ask in the next session also. Yeah. And yeah, you can ask in the forum also. So they should be able to answer those questions. Okay, great. Thank you.
Okay, thank you, sir.